Okay, let's see how this goes. Let's go to Compass, and we are right now having a look at this idea of a square root function. So if we scroll down to number 4, non-polynomials, if Compass lets me do that. One thing we talk about is a fractional power. And like I said, in the case of maths methods 1 and 2, a half, which is what you deal with next year, that means we've got what we call a square root function. So that's what we're going to have a look at now. Square root function, we've got some key points that we've got to work out. And we're going to have a look at that. So let's have a look at a square root function and what it looks like. So square root function is the square root, funnily enough, of x. Now if we graph that, it looks like this. Basically what happens is that we have a parabola on its side. So if we undo that, if we have x squared, that's what we end up with there. The relation, let's see if we can do a relation. Can we do, let's see, history menu? No. Menu, graph entry edit, function relation. We can have x equals y squared, and it does that. So our square root function comes from this part of it. So tab, it's not there. Okay, so it's this part here. So the idea is that if we've got this, we take the square root of both sides, we end up with y equals the square plus or minus the square root of x, which causes, this is the plus square root of x, and this is the minus square root of x part. We'll have a look at both of those. So I am going to change this now. Hopefully I can delete these. If not, I'll just make a new one. Function. Okay. Alright, how do I get rid of this? Delete, can I delete? Oh, awesome. There we go. Alright, so that's what we've got there. So now we've got, square root of x. So that's what we've got there. Now, this graph, like a parabola, we'll draw a parabola as well. X plus 1 all squared minus 2. So like a parabola, which has a turning point, x-intercept and a y-intercept, square root function a little bit different. The only key point that a square root function has to have is this thing here called an endpoint. So it's this one here. So that's your endpoint. That's the only thing it has to have. The reason for that is because it may start here. It may go off that way, in which case it doesn't have an x-intercept, it doesn't have a y-intercept. It may start here and go this way. It's got a y-intercept. It may start here and go this way. It's only got an x-intercept. Or it may start here and do this, and it's got both. So that depends on the structure of the function. Now, I'm going to delete this. Delete? Will let me delete it? No, click it, right click it, delete. Okay, so now just like a parabola, we have I don't like this. Never mind. X minus h all squared plus k, where the h controls the horizontal translation that way, the k controls the vertical translation that way. Likewise, with a square root function, what we have is the square root, a times the square root of x minus h plus k. Now what happens with that is a controls the dilation, and it also determines the reflection in the x-axis. So if it's positive, it's going to do this. If it's negative, it's going to go down there. We'll have a look at that in a few minutes. H controls the x-coordinate of the endpoint. So if it's negative h, it's going to end up over here. If it's positive h, if it's negative h, it's going to end up somewhere over here. If it's positive h, it's going to go this way. K is the y-coordinate of the endpoint. So if it's positive k, it's going to be up here. Negative k, it's going to be down here. Let's have a look at this in action. So we can have 1 times the square root of x minus 1 plus, well, we won't do anything, we'll just leave it 1 minus 1. So there you see that the endpoint has now been shifted across to 1. 1, and if we have a look at it, it goes on forever. It goes on forever in the x values and also in the y values. If we keep going, we'll see it keeps getting higher and it keeps moving further left. So let's see. So what we're seeing happen there is that we're just seeing where the graph exists. So it starts off here at 1 and it goes off to positive infinity. That is our domain from 1 to positive infinity. Its range is 0 to positive infinity because it keeps going up forever. So let's change that around a little. Let's set this to +1. Well, let's shift it out to here to -1. So that's our endpoint there. It happens here at -1. So our domain goes from -1 to positive infinity. Okay, let's have a look. If we make this negative, it's going to reflect it. So as soon as that's negative, it's reflected. So our range changes. Our range changes from 0 and it goes down to -infinity. So that's what we've got there. Now tab up, we're going to change this back to positive. So as we go there, tab, and I am going to add 3. So what do you think this is going to do to it? Well, it's going to move it up. Let's have a look. It's going to move it up 3 units. So here we're at -1 and 3, -1 and 3. So we'll just move this across here. So -1 and 3. If we make it a negative number, we say make it -13. Oops, too far, but we see there it goes. So it's at -1 and -13. That's its endpoint coordinate, and it goes onto there. And all that is controlled by these h and k values, and then a determines the reflection or the dilation. So if we make that a 2, we'll say it's dilated from the x-axis by a factor of 2. If we make it a 5, well, it's dilated from the x-axis by a factor of 5. If we make it negative 2, well, it works its way down. And that's all, and that's what we need to know. There is a slight change, just a little complication, and we'll draw a new one for that. If we have something like 1 times the square root of -x, it will go off that way. So if we have tab 1 minus x, made it multiply 1 minus x, then it shifted across by 1. Okay, the reason for that is, now a lot of you people are saying, you can't take the square of a negative number. You can't. But what happens is if you have -1, let's have a look. Let's go to the calculator page. If we try to take the square root, so let's say this is our thing. Let's define this. We'll call it function. Define g of x equals the square root of x. We'll call it square root of -x. So done, it works, we're allowed to do it. If we set g to 1, non-real result. That's because what we're doing is we're writing the square root of negative, and then we're putting, negative, and then we're putting in a 1, and it's not going to work. If we were to say do g of g of -1, that works, because what we're doing is we're saying we are taking the square root of negative and then -1. Whoops, -1. And we know that a negative times a negative is positive. So what that ends up doing is it reflects it this way. That happens in year 11. We don't have to worry about it at this point too much. I'm not going to look at that. Okay, so how does all this fit in with coding? Well, I'm glad you asked. Whoops. Ooh, we was quick man of saying that. Okay, so what we're doing is we're looking at this square root function. So that's what I'm going to type in. That's what we're going to work with. And this is why there's a whole bunch of stuff involved. So sq_rt, that's what I've called it. You don't have to call it that. It asks for a value of a. So that is our a value. I'm going to set it to 2. It asks for a h value. I'm going to set it to -1. I'm just going to leave it as 1. So it's h, so it's x minus 1. And I'm going to set that k to 3, so it's +3. So this is what we get told. It's asked, so our inputs was a, h, and k. That tells us we are going to be left with 2, which is our a value, x minus h, which is 1, so x minus 1, plus 3. We have a translation 1 unit to the left from y equals the square root of x, translation 3 units up from y equals the square root of x. We have an endpoint at 1 and negative 3, at 1 and 3, so it gets taken straight from this, 1 and 3. We have a domain of 1 to infinity, a range of 3 to infinity, and it's saying x intercepts at false. Why is that saying false? Well, let's have a look at this. This is y equals 2x minus 1 plus 3. Let's graph that. 2 times the square root of x minus 1 plus 3. Well, we're not going to have any x-intercepts. So that's what we've got there. But we do have an endpoint. Check the endpoint, analyze minimum because it's the lowest point. Whoops. I might have done maximum then. Menu. Analyze minimum between here. Why is it doing that to me? Well, I don't like that. Should be giving me a minimum point. That's not the minimum point. It's like a halfway point. It's making me mad. Anyhow, we've got an endpoint. Let's see if we can find an endpoint. Let's try maximum. No, still giving me the same grief. Unless I choose. Whoops. I hate when that happens. Menu, analyze, minimum. Let's try this. Lower, upper. There we go. It's at 1 and 3. It's as though it's throwing a problem. Because I haven't defined the domain. Okay, so it's at 1 and 3. You're just going to have to trust me. So that because of that, we don't have any x-intercepts. So that's why it's putting out that it is false. So your task is to write code that will actually let this happen. It doesn't have to be perfect. I don't have to see this translation 1 unit because you may get a bit mixed up with the syntax, but you do have to be able to identify an endpoint. You do have to be able to identify a domain. You do have to be able to identify a range. And that just comes from this information here. I do expect to see translation information. If you can put in dilation, great. If you can put in reflection as well, that's really good. So for this now, what you don't know, so you know how to ask for input, the requests. You know how to display information, which is this. This comes from something, and this comes from something else, as well as the endpoint and the domain. What you may not know how to do is to write this infinity. To find the infinity, what we do is we go control, this here, and here is infinity. So you would put that all in your code. X-intercepts at false. What do you have to do to your equation to find the x-intercepts? You have a parabola. How do you find the x-intercepts? Well, you should know how to do that. So that's one task that you can work on. Good luck with that.